then. Okay, so let's start the today's class. So we'll start with that simple TCP server where we left off in the last class. So what we were discussing was, I will discuss it again right from the start. So first I'll discuss how to write the TCP server, simple TCP server. Then I will write the simple TCP client. What are the steps that you need to write the TCP client? Then we'll see, try to communicate between the TCP client and server, and then we'll look into the detail that what is happening behind the scenes, right? What is happening when we say connect, or what is happening when we say accept. Once we are once we are thorough with all these concepts, that what is happening behind the scenes, then we'll move on to some advanced concepts, right? Because this thing is very, very necessary once you start writing some advanced networking socket concepts, socket algorithm. Once you write, these things should be clear in your head that what is happening at this particular point of time. Okay. So for writing a TCP server, if my screen, yeah, screen is visible. So what we had to do is, firstly, we'll be trying to do it for a Linux, right? So if my Linux is connected, let me check. Let me connect my Linux box. Connect to host my AWS Ubuntu. And open folder and networking. Okay. I think till here we all set up last time. Yeah. And let me open the terminal. Let me go to build folder. CMake dot. Is it running or not? Yes. CMake dash dash build dot. Everything is working fine. Yeah. Okay. So what will happen is, the first step for creating a TCP server is you create a socket first. So how you create a socket is by doing this. This is the API to create a socket. Okay. So first thing you do is create a socket. And when you create a socket, what does this call actually means is, you tell key what kind of socket I'm trying to create within this API. So AFI underscore inet basically means key you are trying to use the IPv4 mechanism. If you give AF underscore inet 6 like this, it means that you will be using IPv6 mechanism. So does everyone know IPv4, IPv6, IP addressing mechanisms, right? Right. Then the second thing is, it takes whether you are going to use TCP stream, or the datagram, or like UDP or TCP like that. And the third part is, you are giving an option to choose the best protocol for these two combination, which in this case will be at TCP. So this is the third parameter that it says. If you give 0, by default combination for these two options will be selected. That's what 0 means. So for this combination, it is TCP. And you can also give separately, if you want, you can also give it your kit. I want to say TCP I proto like this. I proto TCP, I think. I proto TCP like this. But if you give 0, it will select the, so better to give 0, right? So this is the first step, and then you have to check. So this will return what? Some integer value. In Linux, it returns an integer, and then you have to check whether this returned positive value or not. If it returns 0, means your socket has creation has failed, and it could be for n number of reasons. That may be some failure inside your OS, like it doesn't have a lot of memory to create your socket, something like that. And then you have to always check whether my socket has been created properly or not. In network programming or socket programming, you should always check the return type of whatever API you are using. Just means, keep this in mind. You have to always check the return type of all the API that you are using, right? So my first step is completed. I have created a socket. Now what I'll create is, on which all addresses I want to the server which I am creating. I want to listen to all the particular all the particular addresses that I want to listen. So suppose on your laptop, or on your server, you can have different kind of ports, right? Like Ethernet port, or some 3 4 different NIC and chip and all. So you have to tell on which on which addressing you want to listen to. So
Amit,
what you have to do is, yeah,
one doubt, like you said, AF inet in socket is used for IPv4 or IPv6.
yeah.
but we are also using it in address family. So when we say INADDR any, that means will it only look for V4 IP addresses or V6
No,
IP
no,
addresses?
this address means, so okay, let me take this one by one. So you
Yeah.
have a structure called socket address in that you have to fill, and inside family you have to put what kind of IP address mechanism, same as what you have to give here. So you have to give AFINet for IPv4, AFINet 6 for IPv6. Here you have to give on which particular ports. When I say ports, don't take it that port. It means ki which or NI chip you are into. So suppose in your laptop there could be in uh, different number of chips that you can listen to, right? There could be a Ethernet port, separate Ethernet. You can have a loopback address that it wants to. So giving in address any means I want to listen to on all the ports that I can listen on this particular server, on this particular system. That this is what it signifies in address any.
But it will restrict if I say AFINet 6, then will it restrict only IPv6 addresses
No, no,
or
this is
IP?
no. Here you are saying family or address you are saying.
No, see, if we say INET V4 and then I put ANIDD or any, will it take
Hmm.
all the addresses or only V4 addresses or V6 addresses? Because then this will become redundant, right? This parameter, if we are going to anyway specify any
Hmm. No, any means you are listening on all the ports, is what I'm saying. So
ports,
in
okay,
no, when I'm saying ports, it means ki suppose on your laptop there could be n number of different things where it can listen to. So you can
okay,
have an
okay, got it.
Ethernet port,
Yeah,
you
yeah, yeah,
can
yeah,
have a
yeah.
loopback address. So suppose
Card,
if I give
okay,
here something like this 127.0.0.1, suppose like this, if I give, so what will happen is when you run this server, no, it will only listen to from if any client is in your system, it is connecting to this server. It won't listen to anything coming from outside of this system,
got it, got it. But if
right?
I specify AFINET 6 and then specify 127.0.0.1, then it will be a bit of mismatch, right? Like we
No, no,
specified
this
I.
AFINet IPv4 means what? Like addressing mechanism is there, no? Like 192, 168, 1 dot. This is IPv4, right?
Hmm.
IPv6 is what? Like colon sim hex
Got it,
value
got
thing,
it.
na 20. So this is that signifies that ki whether you are using IPv4 addressing mechanism or IPv6 addressing mechanism, right?
Okay,
So there are two different kinds of addressing mechanism.
okay.
Does everyone understand this? Two different kinds of addressing mechanism.
Yeah,
There are
yeah, yeah.
IPv4. So IPv4 is very commonly used. It's like 10 dot 20 dot whatever we are using now. Then there are, so what happened was it was getting like over, like it was getting exhausted, IPv4 addressing mechanism. And if you see IPv4 is like 32 bits, right? So at max you can have 2 to the power 32 different IP addresses in the whole world. Unique, right? Are you getting this point? So suppose when you write some IP address in IPv4 mechanism, how do you write? So suppose you write it like this, right? 95.17, right? So this all one thing is 8 bits. You get it, right? So this particular thing can vary from 0 to 255. So this particular vary from 0 to 255. Similarly for others. So what happens is each one of them are 8 bits. So that's why 2 to the power it can vary, which is 0 to 255. So when you combine all four, you can have unique IP addresses, which is equal to 2 to the power 32. Getting my point? And how much is
Yeah.
2 to the power 32 if you see? 2 to the power 10 is how much? 1000, right? Or around 1000, 1024, 2 to the power 10. 2 to the power 20 is how much? Around 1
It's 10
million
to
or
the power of
something?
6. Yeah, yeah. A million, and this is about 2 to 4 billion or something, right?
4
2 to
billion
the power.
something, right? So once you have 4 billion unique at IP addresses, now you cannot use that IPv4 in the whole world. So that's when people thought ki it might get exhausted at some point of time. So they started using IPv6. It is relatively new. People don't mostly are not using it right now, but it contains 48-bit mechanism. So now you can have 2 to the power 48 different unique IP addresses using IPv6. And think about it, how much is 2 to the power 48?
Uh,
If
quick
I
question,
pass,
actually.
If I I'll complete my question. If
Yeah, go
I
ahead.
pass socket AF inet 6 and then in address.same family AF inet, will it be a problem?
Yeah, it can have a problem. Like you are telling socket to create as AFINet, and here you in family you are writing as AFINet
Okay.
6. It might, while binding and all, it will give a error.
Okay. Okay.
Yeah.
Yeah.
Okay, moving ahead. Yeah, you had question, right?
Yeah, quick one. And can a machine, so when you're saying like address dot sin underscore
Mm-hmm.
address dot s address, right, that particular line,
Mm-hmm.
now are you saying like you are listening, so am I saying that my server will be listening to like two IP addresses or any number of IP addresses assigned to my machine? Like if I have like two network cards, does
Correct.
it mean I will have
So
two
I'm,
IP addresses and I can listen to both of them?
yes, yes. I can listen to all of them.
Oh,
Yes. And then in this you have to assign the which port I want to listen to. So this is different port. Like this is what we are discussing last class. No, this port is associated with one particular process. So when I say, suppose in this, if I see here, I am saying that I want to listen to 8080. So I am saying this 8080 particular thing will be associated to my this particular process which I'll be running, this server.exe, this executable. So whenever any data that will come to this system for this particular IP address, and it will see it has come to for 8080, my OS will know that it has to go to, this will be served by this particular process. This is the importance of this particular port, this one, right? So don't confuse this port with your actual physical ports, Ethernet cable and all. This is something related to software that you are writing. This is right, and those are physical ports that we call USB port and all port. Don't get confused with these ports. People I've seen get confused with these two ports. When I said port, this is some particular integer that your server will be listening to, and this particular port, OS use it to recognize for which process that this data has come, and it will throw this data whatever has come to this particular process to serve, right? Is everyone clear with this? What is port, this particular port? So if I say I'll be suppose listening to 9000, whenever any data come to this system, first it will come on a particular IP address what my system is, and then OS will know, okay, it has come to me, but which process it will get served by. So it will know only through this particular port. Okay, it has come for 9000 port, and 9000 port this particular server is associated with. So I'll give it to this particular process to handle. Got it?
Yeah.
I mean, I have a question. Like, where are we
Your
seeing?
voice is not clear.
Okay, I think I'm audible now.
It's audible, but it's not clear.
Okay, I think it's good enough, right? Is it still
You can
noisy?
repeat your question once.
All right,
Yeah, so port can be go till I think 65,000 or something, but there are some ports that you cannot use. Those are like preoccupied for certain purposes. Like for HTTP, the port 80 has been occupied, or for HTTPS 440 has been occupied. So these are some standard ports that particular process uses. So you should avoid using those. So when you are writing, suppose your own HTTP server, then you should try to listen to 80. So when you give any particular URL on the Chrome, suppose Chrome browser, when you say suppose google.com, right? So automatically it takes port 80 for HTTP, and if you are using HTTPS google.com, it will take 443 port by default. So you don't have to give the port. Chrome will assume it is 443. Similarly, when you are doing SSH, right? When I was doing MOBA XTERM, I was using to connect to a different server on AWS. So it was by default, it was using port 422. So these type of ports that you should avoid when you are writing your own servers, which are like preoccupied for certain kind of protocols, right? Okay, so moving ahead. So after we have put in our address and port and all, which all I have to listen to, you have to do what? You have to bind this particular socket that we have created here, which is server FD, with this particular address that we have created, and this particular API takes in this particular structure. So we are converting it to this address, we are converting it to this particular structure, and then this size of address it takes, right? So this is how the API works. It takes the server FD and this particular address as a socket address star structure and then size, right? Don't think too much about it. I mean, this is how this API has been defined, then this is how you have to put it. And these are the steps that you have to take to create a server. Like, there is no rocket science in here. These are the steps that have been defined by Linux OS, that this is how my socket will be created, right? So you are binding the socket with the address. So address on which you are be listening and the socket you have created. Now these two are combined together, right? After this, you will tell, now I am ready to listen on this particular socket. So so understand this first. So once you are creating a socket on the OS layer, there are few things that OS does, right, in behind the scenes. So once you have created this socket, what it does is it creates some kind of buffer which is associated with this particular socket. So what kind of buffers? So there are three major but particular buffer that is created. One queue is created which is called accept queue. How many, whatever the connection that will come for this particular server, it will keep queuing into that one particular queue, right? Then there is receive buffer that is created. Some buffer will be allocated for this particular socket. So whenever any data come for this any data that comes for this particular server, it will first get inside that buffer, OS ka buffer, and then it will be given to this particular process ka buffer, right? And similarly, there is a send buffer that is created by the OS. So remember these three things, very important. There are, whenever you create a socket, OS allocates some kind of buffer for you for this particular socket, which is associated with this socket. Receive buffer, send buffer, and some accept queue to queuing the connections that is coming, right? So when you are saying listen call is something that telling OS ki now I am ready to accept the connections. It is a like passively active now. Ki now I am ready after this. And what are the two parameters it takes? One is the FD, that is we have created this socket FD, this particular we created from the socket. And this second option is the backlog. What is backlog option? And does anyone know what is this backlog option? So it actually signifies how many number of clients at any particular point of time will be getting served, will be queuing into your queues. So think of it as size of your queue. So suppose what will happen is, suppose 10 clients are coming at parallelly, 10 clients started to come and trying to connect to your server, right? And suppose your backlog value is 5. Suppose, for instance, you have given the value as 5. What will happen is, uh, it will it will take one connection, the server will take one connection, and suppose your code is like that, it will take connection, it will start serving your request, right? Meanwhile, all the other connection will start queuing in your connection queue, right? And it, because its size is 5, which you have given here, only 5 connects, till 5 connection it will get queued. From the 6th connection, client will start getting okay, you will not be able to connect, connection will start disconnecting, means you will not be served by this server. So this is what backlog means. So at any one particular point of time, you only these many connections will be allowed in the connection queue. After it is filled, other connections which are coming will not be served. It will say server is busy or whatever. It will not get served. This is what this listen means. And this is, you have so depending on your algorithm, depending on how big your system is, basically you will choose how many number of client connection parallelly you want to process. Not parallelly, it means how many number of clients you want to queue, so that this my server can take in from the queue and then start serving, right? Yeah,
Amit,
connection
can you
gets
repeat?
refused.
Yeah, can you repeat the three things you said? Send, receive buffer, queues,
Send buffer.
and send buffer. And in this, one buffer is in the operating system, one is in the process.
No. All the three buffers which I'm saying is all created by the kernel itself. These are all in the OS. Whenever you create
Okay.
a socket, these three buffers are created in the OS, and this socket is associated with this buffer. So
And
whenever you
queue is the
yeah
one which keeps the number of connections, and the buffer is for every connection. Yeah, every
buffer is for per
yeah,
socket.
per socket, right?
Yeah,
And queue is the list of connections. What you said, backlog.
yeah, backlog. So number of connections that will be held in the particular queue. After, if after that, if any connection come, it will be refused. Basically that connection, that client connection will not be served.
Okay.
Right?
And all this is happening in listen call?
No, not in listen call. Listen is just telling ki my queue size will be this much. This is not happening in listen call right now.
So in the
I'm just trying.
bind? Not
Yeah,
even in
I'm
the
telling
bind?
you. No, not
Okay.
even in the byte. So
Okay.
after you have said listen, OS is now ready, that your process is now ready to start accepting connection after listen. When listen is done. So again, I have told you, for every API call, you should always check what is the return value. If it is 0, you should assume that this particular API did not work, and you should actually return failure, right? So these code are important. You should not just say listen and then move ahead. You should check what is the return value. So this is very important in socket programming. You should always check the return value of all the APIs that you are using. Okay. Okay. After this, what I'm doing is this is the point where this is the blocking call, except. So this is the API where I am my process will get stopped and say, okay, I'm waiting for the connection to come, right? And remember this is a blocking call, right? So whenever my code comes here, my except it will stop here and keep waiting for any particular client to connect to my server, right? So suppose I have ran this code and my code came here and it stopped. Now no client has started connection. Now suppose I start running connection. Suppose from Chrome I said connect to this particular IP and port, right? So suppose I was listening at 8080. So I'll say connect to this my server IP address :8080. So at that point of time, if connection is received, my OS will tell ki, okay, now some connection has come from that queue. Remember the connection queue. It will take out the connection and it will then return from here. The accept will return what? The new socket. And what is this new socket? This new socket is pertaining to the new client that has come. So what will happen is when a new connection came from the client, the OS will again create a new socket for you for this particular connection, for this particular client. And again, same thing, the receive and send buffer will be created that will be attached to this particular socket.
Amit, I didn't follow. So initially you have already created the socket and binded it to the IP
Yes,
address.
and that is a listening socket. That is different.
Okay.
And you are listening on that particular socket which you have created earlier.
Agree. Yeah.
So now when a client connection came, right, OS
Okay.
will return you okay, now new connection has come. It will put it in that queue. Remember this listen wala queue that I have told.
Yeah.
And accept will take that particular connection from the queue and return what? A new socket.
Okay.
New socket. And now this socket actually means this is particular to a particular client that has connected. This is the different socket now. Don't confuse this socket with this socket.
Got it. Okay.
This socket will always be used for listening.
Got it. Yeah.
And when accept returns what? New socket. And again, when a new socket is created, OS internally will assign you some buffers associating with this socket, some receive buffer, some send buffer internally, right? So now, and you will see this particular, if new socket is written positive, this new socket integer value, it is always an integer value. If it is positive, means fine. What I'm saying is my connection has been accepted. If it is not, then there is some error, and you should check the failure. Is there any error or not, right? So if my code has come here, it means I am connected to that particular client, right? And see and think internally what could have happened inside this. So what could have happened is, because it is a TCP socket, when I'm saying accept, what would have happened internally is, when I'm listening to this particular connection and client has connected, first three-way handshake could have happened, right? Remember, TCP has a three-way handshake to start a connection.
No
Does
idea.
everyone know this?
Yeah,
So what?
SYNAC and
Yeah. So internally in accept, when accept is called internally, you don't have to do it. Internally, what will happen is, because you have said that this is a TCP socket. Remember, when you are creating socket, you said this is a TCP socket. So what will happen inside it is, when a client is coming to for your connection, first what will happen internally in your OS layer, what will happen is a three-way handshake takes place. So what will happen is, first the client will send first the client who is connecting to your server, it will send ki, hey, I want to connect some kind of buffer. It will send some data that you can see in the theory what it sends, right? And then your server, it will acknowledge ki, yeah, I have received your message. We are ready to connect. And then again, the client will send, okay, I have also received your acknowledgement, and it will again acknowledge the acknowledgement. So three way. First client to server, server to client, and then client to server again.
I think so. What is the name of this three-way acknowledgement? Somebody was mentioning it. So it's like some SYN-ACK.
Yeah, SYN-ACK. Like first it is
Okay.
first the client says SYN packet. When I'm saying SYN, think of it some buffer it is trying to send. In very overview is think of when I'm trying to connect to you, I'm sending you hello. You are sending, hey, I have got your message. I am saying, okay, yeah, I have acknowledged that you have got your mail. I'm acknowledging back. Okay, yeah, you whatever you sent, I have also received. So whenever three things have happened, then my OS says, yeah, the connection has been completed. Then
Good.
after that, my accept returns a socket, this particular call. So internally, that is happening, three-way handshake, right? So that's when we say TCP, we think of it as connection protocol. The connection is created between, and when we say connection, what is it? This particular three-way handshake. So my client knows who is my server knows who is my client. Everything has been acknowledged. Then this particular call returns and give us a new socket, right? And this new socket is pretty specific to that particular client who has connected now, right? So once I have my code has come here, I am sure that my connection has been accepted. Is this clear till now? So today's class will be very basic because I want you to take, if your basics is clear, only thing required after this is you're writing your business algorithm. That's it. If your basics you will not understand ki when is accepting, what is happening internally, you will not be able to write a proper good business logic.
One query,
Right?
Amit.
Yeah.
So at line number 87, you are getting a new socket, but there can be multiple new clients connected, right?
I have one
Yeah.
doubt.
Okay, hold on. I mean, there could be multiple clients connected, so it should be not it's under a while loop, right? Because if
I'll tell you. Correct. You are correct. I'll tell you. So I'll
Amit, I
go
had a
one
one
step.
query.
Yeah. Tell me. Tell me. You are not audible if you are speaking.
Hello. Yeah. I am.
Now you are audible. Tell me you are audible now.
Okay. Are you able to hear me? Okay.
Yeah.
Okay. Yeah. No. I had one doubt actually. In that we have that SYN-ACK and then SYN-ACK and then again acknowledgement is sent, right? If that for acknowledgement what the client sends in the TCP, if that means the receiver did not give any this one, right? Again it will like to keep on sending acknowledgement also this TCP client.
You are sending the acknowledgement only failed. It did not reach the server.
Yeah.
No, it means the connection did not accepted only. So accept will not even return this particular call.
Accept will not return.
So only until all the SYN-ACK is
from
completed, only then it will accept will return. So that is happening behind the scenes in the accept call. The OS is doing that. The TCP layer is doing that. We are just above the TCP layer. This accept call or socket call, this is calling on the OS layer, right? We are sitting on top of TCP layer right now. Think of it like this.
Okay, thanks.
Amit, is it possible to see the information like SYN sent acknowledgement is received? Those information, is it possible to log here?
We won't be able to log in here, but you can see it if you use you can use a Wireshark tool, and you can see that SYN-ACK will be happening. Let me show you also.
Amit, can you please explain the buffer concept again?
Your voice is not clear.
Can you please explain the buffer concept again?
Yeah, what I'm saying is, can you mute? A lot of noise is coming. Yeah, what I'm saying is whenever a new socket is created, no, internally, what OS does is it creates some buffer, send buffer, receive buffer, and associates with this socket. So something which is happening on this particular, suppose this particular socket wants to send something or receive something, first it will come to this particular buffer that has been associated with this socket, and then it reaches the user space, right? So there are two kinds of whenever a process runs, there are two things that happen. One is a user space and one is a kernel space, right? So whenever you are giving such calls like accept or listen, it goes towards the kernel space. So there is a shift happens, right? So inside the kernel, there is a space buffer that has been created for this particular socket. So whenever something gets received, suppose, first it will copy in this particular buffer, which is in the OS layer, and then it copies back to your user space, right? Let's see the code, then you'll get understand what is happening, right?
But by user space, you simply mean the memory address space occupied by user programs, and kernel space is memory address space occupied by the kernel itself, right? The
Yes,
OS.
yes.
That's
Yes. Whenever do you do so, this is not specially uh, this is not something specific to networking. This is for anything where whenever you do a system call, no, any
yeah,
particular system call,
yeah.
your what your system does is it stores everything everything related to your process in some registry and then shifts to a kernel space, your CPU, and execute the whatever is in the kernel, whatever the code is for that system call. Whenever something is, suppose something is returned by the system call, then it shifts back to the user space again, and then that value is given to the process, user process. So
And this send, so this so the accept and send receive buffers for a TCP socket, where do they so you're saying they live in the user space, or they'll
no, those buffers are created in the kernel space. You cannot
okay,
see it. As a
okay,
process, you cannot,
makes sense. Now
you
now
have some
understood. Yeah,
control, but and will tell you how to control those buffers also, but
okay,
not directly. There is a API given to control it, not directly. You cannot touch that buffer
got
directly.
But
है ना?
then Amit, what is there is a TCP protocol also running, right? Provided by the operating system.
Yes.
So there should be some buffer there also, right? I think there is some sliding window also happening over there, sliding window protocol.
Yeah. So
So
those,
उसका और इसका connection कैसे होगा?
नहीं, so that buffer only that you are talking about, that buffer only. Whenever, so that TCP what you
Okay.
are talking, no, that buffer only we are talking. So those are
But
in
फिर वो
kernel
process
space
space
only,
अलग
no?
नहीं हो जाएगा?
Sorry,
वो process
process.
space will won't be different than this process space, because this is a user process, and that would be, I believe TCP protocol is running in a kernel process.
Yes, so that is kernel. That's what I'm saying. Na? Those are created in the kernel buffer, not the
Okay.
user buffer.
Okay, got
Right.
it.
Okay, so these things will get more clearer once you see the code. Right. So once I have reached here, my connection is accepted. Once my connection is accepted, now I can do a send and receive with the particular client, right? So what we can do is there is a API call called read, or you can also use receive. Both are synonymous. Only thing is it requires one more parameter, receive. If you do a read, this fourth parameter is not necessary. So both can actually do a read. You can either say receive or read. On Linux I'm talking about. We are only talking about Linux right now. We'll see for Windows also. Okay. So if suppose I say receive, what does receive takes? So receive is saying, so receive is also again a system call. So what I'm saying is now you can receive the data on this particular socket. Which socket? Remember this socket, which is now specific to a particular client now. Now, whatever the send and receive that I have to do with that client, I will do with this socket, not with this socket. Remember, these two are different sockets. This socket is only used only for listening and accepting connection. Once connection has been accepted, every send and receive for that client will happen with this socket now, right? It is getting highlighted, no? Yeah. So now if I have to do receive something from that client, I have to do receive on this new socket. Remember this, right? And I have to send some buffer. Key, okay, whatever has been received, you put inside this buffer. What is this buffer? I have created this buffer. If you see here, this particular buffer. So right now I have created by simply taking some 1 KB buffer I have taken, right? So 1024 is some 1 KB bytes. 1024 is 1 KB. And this I am sending in the receive call. buffer, and it takes also the size of buffer, whatever the size. So right now my size of buffer is 1024. You can also give it like this. If you don't want to directly hard code, you can also give it like this. And the fourth parameter is how much you have to wait. That fourth parameter I will tell you later. But right now just think you have to put 0 right now. I'll tell you what are all the options that is required as the fourth parameter, right? So for receiving the data from the client, what you need is the new socket that the client accept has returned, the buffer in which the receive will be the data will be given to you on the user space, and the size of how much the buffer size it is, right? So now think of what will happen. So suppose client has sent something. We'll look at the client code also later. What will happen in send? So suppose just assume कि client has sent something and it has come to your system in your network interface card. It has come. It will go through those layers, IP layer and physical layer. Physical layer first, IP layer, and it will remove all those headers. These are all from OSI model. I'm telling you. First, it will remove the IP header. It will give it to the higher this protocol, right? Then it will remove the TCP headers, and then whatever the actual data, application data that the client has sent, what will happen is first it is coming to that receive buffer. Remember the kernel receive buffer. This data, whatever the client is sending, it has come to the kernel receive buffer, right? And when you are doing that receive call, what will happen is this is also a blocking call. Remember this is also a blocking call right now. So what will happen is whenever my code comes here, it will wait on the receive and it will check, is there anything on that receive buffer right now or not? In the kernel wala buffer, is there anything or not? If there is anything, the kernel will copy all the data from the receive buffer and it will put it inside this user wala buffer that you have passed. Copy will happen, right? From the kernel buffer, whatever is received, to your buffer that you are passing, right? And once it has received something, it will come back. So see these two things. You are sending a buffer and the size of buffer, and what it is returning how many buffers you have actually read. So these two are different values. Whatever the size of buffer you are sending and whatever the size of buffer you have actually read. So what can happen is, suppose for this moment, for this code, I have sent how much? 1024 bytes, right? But what can happen is like client might have sent just hello, right? It is just 5 bytes. So even though you have sent 1024 bytes to read, my kernel buffer has only 5 bytes hello. It will copy the hello into this buffer, the user buffer that you have sent, and it will return what? 5. Okay. Whatever you buffer size you have sent, that is okay, but I am because I have copied only 5 buffer in your user space. This is the value that is getting written. Val read. Are you getting the difference? Whatever buffer you are sending and how much buffer actually has been copied to your space. This is getting this is the data. It is come from here. Val read, right? So this is, you have to check this value. How much data has actually came, whatever the data, how much actual data I have actually read inside the buffer, not the whole 1024 bytes, right?
Just one question.
Hmm.
Let's say the client is so because you were talking about this, that the underlying layers are stripping off some headers and all, like TCP header and etc. So just one question. Let's say a client is sending a message which is long, like 1024 characters.
Yes.
My basic understanding is that over the physical layer, this message will get packetized, right?
Yes.
So then are there some, so basically it's the job of those layers below TCP IP, which will like assemble this back into
assemble. So suppose it's a 1024 bytes message that has been sent, but while sending also it has been packetized, right? So suppose I don't know, like suppose 500 bytes 2 packets has been sent. So it will have a serial number 1 2. This is the first packet, this is the second packet, 500 bytes of first packets, and inside the TCP layer it will be all accumulated, combined into, okay, this is the first 500 byte, this is the second 500. It will combine and it will keep going inside the receive buffer, OS ka receive buffer, right? And the moment you do this API call receive, there are two things that could have happened. Either you would have already received all those buffers whenever you have given this receive call, or there is no data in that receipt. Until now, I have not received any packet. There are two things that can happen, right? When you are giving that receive call. So if there is no data in that OS wala buffer, in the receive buffer, what will happen is it will just keep blocking here. This code will not move after here. But the moment it has some buffer in that OS wala, so what OS will do is copy that OS ka receive buffer into your buffer that you are sending in this API, and then return how much actually has been read. Correct? This receive should be clear to everyone how it is happening.
Amit, I think there could be one more thing which can happen, that the OS buffer has say 2000 bytes, but our buffer is 1024, so we can read only 1024. So in that case, will the return value change? Because I think there is one scenario like that also, where it will say -1 and then you increase and read again and again.
No, so I'll tell you. So what will happen is, suppose you are saying you have sent 1024, right? And
No,
suppose there is
the client has sent 2000 and we have a buffer
2000,
of 1024.
yeah. So what will happen is, once you send 1024, and suppose all 2000 bytes has come, right, in your buffer. So it will just copy the 1024 bytes, because you have given the size of only 1024 bytes in your buffer, and it will return 1024 because it has copied 1024 to your buffer, right? But the thing is that now there are some other buffer that is remaining in the OS kernel which has not been copied to your buffer, right? So in that case, you again have to go and do again receive call to again read those extra those are left.
Okay. Okay.
Right?
Right.
Getting my point?
Okay.
Yeah.
We
Amit,
can have a while loop also, right?
Yeah. That we can do. So I will take that. So I'm just going through this basics, but basics is clear. Then it will start getting to you. Okay, if I'm not getting copied everything, then again I should loop inside, right? And this will only happen when your basics are clear. Ki what is happening behind the scenes. Okay, so now suppose I can.
Just one more quick question.
Yeah.
Just to clarify, when a new packet comes, so the operating system will redirect based on port. After going through the port redirection, when it will come to the particular process. After that, the whatever the new packet has information, if it has in some information, it will be stored inside the OS buffer, that is handled by the kernel. We are reading that kernel buffer using the line number 97.
Yeah, reading that. No, not directly reading the kernel buffer. In this call, what will happen is it will check whether there is any data in the kernel buffer. If there is data, it will copy in this particular buffer that you are sending. Copy will happen.
Okay. So
And then it will return how many number of bytes has been copied in your buffer.
okay. In our case, the client just got connected. Let's say the server. So there is nothing the client will send now. So 97 is just like. Is it like that? Because
Yeah,
because
it will keep blocking. It will not move away from here. This line it will stop at this particular point of time. Your code will not move after this until unless there is some data. That's why I'm saying it is a blocking call.
no.
Can
What I'm saying is, so okay, when a client sends a request, that is also get copied into the OS
No,
buffer.
when a client send request means that is when you are saying connect, there are two different things. One, the client will send connect, and then there is thing that client is sending data. There are two different things.
Okay, so in our case, in this code, like for example, this code, the client is not sending any information to the server. Only the server is sending back a hello response.
Okay.
So, so the line number 97 is not doing anything because the client is not sending anything, right?
So if your logic, if your business logic is something like when client connected, but client is not sending anything, my server has to send something, right? This is what
Yeah,
you're saying, right?
yeah. If that is
But then
happening,
in that case, this call should not be here. Otherwise, you will be blocked in the receive. You will not even go to the send.
okay, yeah, got it.
Right?
Yeah, got it.
So my code will change like that. If I know ki whenever somebody connects, I have to send something as a server, my code of sending should be above.
Okay, yeah, got it.
Right? If you do a receive and nobody is sending anything, your code will get blocked there.
Okay, okay, but this code executes without getting blocked because when I just run this code and sent a Chrome request to the local host, So it is executing without getting blocked.
When you send the Chrome request, it actually the
It is
receive
actually
call from
receiving,
the
right? You are sending, or when you are sending a request.
Okay, even a request is a data that is sent by a client.
Yeah, it will have some HTTP request. If you see, no, if it will be HTTP 1.0, there are some particular request that you are sending.
Okay.
It has some data buffer that you are
Okay.
sending, and that will get received by this receive.
Okay. Okay.
So it's not like it is not sending anything. You create your own
Amit,
TCP client and then try to not send.
Okay. Got it.
Yeah.
Amit, one doubt you told, no, there is a blocking call that RECV, that is 97. So maybe then that is that, whatever that actual function we called, right? That function implementation may have some kind of a while loop, and also that if there is no data, it will keep on anticipating data, so that it that function itself doesn't return. So that you don't your 98 will never execute if you don't have any data. That is right.
Mostly it
Something.
won't be a while loop, because again it will be a waste of your thread and all, no, CPU cycles and all. It will be mostly like it will see okay, there is no data in, there is no copying that is happening, so it will just thread is that is blocked there. That's it. I mean, if you keep on looping, then that thread is doing some work.
Yeah, but yeah.
Again, your voice is not clear. Some
Yeah,
problem from
yeah,
your end.
maybe I
Everyone is not
sleep
hearing him
or
correctly, right? Or is
something
it just me?
which that
Yeah, yeah.
platform. No.
Gajanan, you are actually
Sorry.
cracking up a bit.
Yeah, correct.
No,
So
no.
I'll
Either it could be a while or a sleep or
okay.
something.
Let's move ahead. Can you mute? I mean, we cannot hear you actually, Gajan.
Uh,
Okay, so I'm moving ahead. So let me finish this off first. So suppose I have read something, and I can also see I'm doing a receive percent, whatever the buffer I've read. I can also create a string out of it. So if you want to create a string, this is the way you can create, right? STL string that I'm saying. So this is the buffer that I can give as a in the constructor, and this is the data how much I have read, right? So you can actually create a string out of it, right? So it will suppose hello has been read, so S will contain hello. So you can do a C out S, right? It will print hello. Is this clear? Right? Moving ahead.
yeah.
Okay. So remember this, that there is a difference between this length of buffer what you are sending and the value that has actually been read, right? So keep this thing clear. So it's not always that you will receive that many data. How much size is the buffer? It can be less, or right. It can be equal or less, not more. Whatever the size you are sending, right? So, and what will happen in send now? So let's look at the send also. So now from the from the server side, I'm trying to send suppose hello to that particular client who has said from where I have received this. So what I'm doing is, again, if you see the send, again, I'm sending it to this particular socket. So whenever I'm doing a send or receive, I am doing it on this particular socket from whatever the accept return. So this socket is very specific to this client. Whenever I have to do a send and receive to this particular client, I have to do on this particular socket, right? Not on the listening socket. Remember this. So receive I have did on new socket, and again sending for that particular client I again have to do on the new socket. And what do I want to send? So this hello I might have done somewhere. So see, this hello is hello from server. This is buffer, right? This is the buffer. Hello from server. I have put a string. And if you see here, again, it will take the same thing, socket, buffer that you want to send, and the size of that buffer. And then this is the fourth parameter that will tell you later. But for default values, keep it to 0, right? So very, very easy stuff, right? Just the socket, whatever you want to send, and the size of whatever you are sending. But internally, what would be happening that we have to see? Whenever you are doing send, what is happening? So send is again a system call. So what will happen is, whatever the buffer that you are sending, first it will get copied to the send buffer, right? And then the OS will take care of sending it. So the TCP layer, whatever the algorithm, it will, suppose it is a very big string, so it will slice it down to small packets, and then it will send it to the other side to the client, right? So when you are doing a send, it will actually first copy the buffer from your user space, this particular hello, to the kernel buffer. Don't think of a send as that it is already sent. It is just copying from your buffer to the kernel buffer. And then kernel will take care of sending it. So what can happen sometimes is, suppose you are doing a lot of send calls on this socket, and maybe your system is little slow in sending the packets. So whenever you're, suppose in that case, when you're sending, and then your kernel buffer ka send as full right now, it is cannot accept new send now, right? So in that case, your send will get blocked until you have some new buffer space that is available, where you can put your hello string again into that buffer. Are you getting, is this point clear? So in that case, your send can also be blocked until unless your all the buffer is getting copied to the kernel buffer. Is this clear?
Yeah, hi Amit. I have one small doubt here. Am I audible, right, Amit?
Yeah.
Yeah. Amit, I think whatever we are talking about the kernel buffers, right? It's per socket basis, right? I think it's a per client basis,
Yeah,
right?
it's a per socket, yes.
Whatever the receive and send will be based on the per client only.
This part. So suppose if I go back to again accept and a new client comes, so this will be a new socket that is very specific to that other client. And for that other client, it will have a separate send buffer and receive buffer.
Got it.
Hai na?
Another small point, Amit, when you said about the receive, right? Whether it will copy or entirely it will move the data from the kernel buffer to user, please.
Sorry, come again once more.
So when we say that when we're receiving the data, right, using receive call, at
Okay.
that time, whether it will copy the data from the kernel buffer or it will move the data from the kernel buffer to user.
It will
Move
copy and then delete, like it will be move only.
and delete. Okay, sure.
Yeah, it will empty up the buffer space to get the new data.
Got it.
Right. So it also has some fixed buffer only. It's not like there is infinite buffer. You can also check how many buffer space that kernel has through some APIs that you can check, and that you can change also. So suppose by default, suppose your kernel buffer space for receive is 65K. Suppose somebody have find it is 65K. That you can change according to your algorithm. Okay, I think if I have some bigger kernel buffer space, I am getting more speed or more throughput. So you can change also that buffer space, kernel ka buffer space, through some APIs.
Got it, Amit. Thank you.
Yeah.
Yeah.
And I'll
Amit,
tell you what APIs to use. Yeah.
Amit, one more doubt, maybe slightly advanced. Like if the kernel buffer is full and the client tries to send some data, what kind of error does it happen? Of course, it should happen in production servers, right? Sometimes
No,
on over.
it won't give you error. Means it will try to empty the space by giving it to your buffer, but it will, like what will happen is, suppose client is trying to send a lot of data and my buffer is full. So at TCP layer, no, it will send a packet telling stop. I am not accepting new data. Just slow down. So these are
Okay.
happening at the TCP layer. And then there
Right,
is a
right, right.
concept called window resizing, and there's what is
Right,
that?
right, right. Yeah.
Window, right? So suppose my client is very fast. Suppose 100 clients has come and there is just one server, and everyone is trying to push data to the server. Now at some particular point of time, my buffer is full, right? My
Hmm.
receive buffer is full. So what will happen at TCP layer, my algorithm of TCP, it will say, hey, I am full right now. I will not be able to accept new data. So stop to the client. So the client side, it
Okay.
will get the packets will start sending slowly,
Okay.
right?
Yeah,
Is it
very
something
good, very
like
good answer.
rate limiting?
Yeah. So yeah, this is kind of rate limiting algorithm and window sliding mechanism techniques that happen, right?
Right. Because I was asked this question in one interview where they said that if there is a problem between client and server, then how will you figure out troubleshooting? Where is the problem, on the server side or on the client side?
And like what kind of problem? Is there any
Uh,
specific like?
yeah, the same. Like if there is congestion
Uh,
on
So
the
we'll talk
network.
about quality of service and congestion,
Okay.
right? Once
Yeah.
we have done, we'll talk about QoS. QoS is a good topic to understand, right?
Okay.
Quality of service.
But I
So
think this
yeah,
is what you
basically
answered
this.
now.
Yeah, basically this happens. Ki when I as a OS layer, when it sees ki my buffer is getting full, I'll be jammed. It tells I'll not be accepting more data right now. Just stop or slow down a bit like that. So as a user, you don't have to take care. That is happening in that TCP algorithm level. Right. Okay. So
Right.
is send and receive clear? Accept, listen, accept, send and receive. So if we see once again, what do we have to do for the server? We have to create a socket. We have to assign up which on address we want to listen and which port. And we have to bind our socket with that address. Then we have to send a listen, and we can give how much backlog we can want, basically the queue size. And then accept. Once some client comes and accept, you can do a receive and send on that particular socket with that particular client. So this is how the whole server looks like, right? So whenever you have to create a server, these are the steps that you have to take. Till here, it is all same. It will be remain all same till accept. After accept, what do you want to do? You want to send first or you want to receive first? It is all your business logic.
But in which API this buffers are created? Accept or receive?
Once you create a socket,
Okay.
buffers are
Okay.
getting assigned for accept one. This socket is created for the listen socket, right? So this socket some buffer will be assigned as per, because it is a listening socket. But when this particular socket is created, when we are doing accept, because we know it is for the client, receive and send buffers are created,
Okay. Got it.
right? So these
Amit,
two are different.
I was
So first
doing
that queue is created. No,
Hmm.
not queue.
Queue for the accept.
Okay.
Yeah. So can we move ahead?
Amit, I was just doing some Googling on the fly. So it's like online. I also read that if you were to use a UDP socket instead of a TCP one, only the receive buffer is created.
Yes.
So why not
So
send buffer?
So let me come to UDP, then we'll discuss. So in UDP, what happens is these things doesn't happen, except call, listen, call doesn't happen. It simply is send to and receive from. That's it. There is no
Okay.
TCP handshaking mechanism that is happening and all in
Not
UDP.
many guarantees. Okay.
Yeah, no guarantee and all. Right. So when we look at UDP, I think I'll take half an hour something for the UDP, maybe next weekend probably, and we'll check there, right? But for the server, everything is clear. What is happening inside? What is happening, right? What is happening when somebody is sending? What is happening when somebody is receiving, right? Everything's clear. Okay. So quickly, let's also see from the client perspective what is happening. So if I just add, what should I do? Should I add here only? Let's call it client, right? And for the client code, I have some code that I will just copy paste. Otherwise, it will be too much task to write a lot of things. And I'll just go through what all we have to do in client side. Okay. Format. Like WebLogic has multiple processes in different ports simultaneously means you want change our implementation requires. Okay. Let me finish this TCP server client first, then we'll look at how WebLogic or Tomcat might be happening. Those are some business logic that is only happening. But let's first concentrate here, see what is happening. So so that was from the server side. Now let's talk about what you code you have to write, what steps you have to take to create a client, TCP client, right? So not a lot of difference. So similar to what we are doing in server, we have to first create a socket, and you have to define what kind of socket and what kind of IP address family, right? Address family. So I want to create a TCP type, so I will create a socket stream. So same socket I have created. Then there on the server side, we were talking about what address I will listen to. Now here again, I have to create a server address, but this address is where I will be connecting to, which server I will be connecting to. Right now we are writing the code for the client. So as a client, I have to know which server I have to connect to, and which server I will know it through IP and port. So IP will give me a system and port will give me a particular process. Right? So this is that particular address I'm trying to create. So suppose I'm trying to go on server port, which is my 8080 on which my server was listening. And this is the IP. I can even give it local host or any particular IP that where server is running. So suppose server is running on 10.20.30. So I can give it here. Right? And then you have to do this. Once you have to use this IP to create. Once you have to know these steps, that how to create and how to bind everything, IP address and all. These are some necessary steps that you have to take. Here it is doing is it is taking server IP and it is converting it to the some text to binary format. And here I'm assigning which port I'll be listening to. That you don't have to get your head into too much. Just know ki this is what steps you have to take to create a client, right? And then finally, once you are done with this creating address structure and socket and all, what you have to do is you have to call this function connect. So this is slight difference from the server. Server was doing accept, client you have to do a connect. Got it? And let's see what happens when we are doing connect. When you are doing connect, the same thing. What was happening inside the accept call it is happening inside the connect from the client side. So once we are doing a connect, think of it as TCP handshake is taking place internally. So there accept, here connect. Now when both these calls meet, connect is sending this SYN packet, and then there it is server will be sending SYN-ACK packet, and then again I'll be sending ACK packet, right? So this is all happening. Once that is done, okay, all those TCP handshake has been done. So at that point, my connect will return. If that doesn't return properly, we need to check. If it did return, if it returns 0, it means connection, we are not able to do the connection, right? But if
I were connecting not to a server that I have written by myself, like here I'm just coding the server up by myself, but if I was connecting to a standard HTTP server, I would have used port 80 instead, right? Not this 80.
So if it is HTTP port 80, if it is HTTPS port 443, right? If it is a SSH port 22, right? So yeah, the same way you can change this particular server port that you can change, right? And then, so is this clear? What is happening inside connect? When will it return?
So one question: this port and the server listening port can be different, right? Server can listen to any port, but when we send out a client request, we need to follow the HTTP. If it is HTTP, we have to do the 8080, or if it is HTTPS, we have to follow that particular port number, right? Is that what you mean?
No. What I'm saying is, as a client, when you are writing the code, you will decide, right, which server I have to connect. Right. So suppose if you want to connect to the server that we have written earlier, like this server main.cpp, this particular server. So where I'm listening to 8080. So if I, as a client, I want to connect to this server, I will say 8080 port I want to connect to.
Okay.
So suppose if I create some other web server, suppose next week I create a web server and suppose I'm listening on port 80, then as a client, if you want to connect to that, you will say port 80 I want to connect to.
Okay.
Is not clear?
So suppose one more client is there, then we will have to change the port, right?
Port of connection? No.
Yeah, because
it's the same server. No, if you are connecting to the same server, it has to be same port.
Same port. Okay.
I mean, there will be multiple. I mean, it will go in the queue or whatever, right? It will go in the connection queue, and
that's what I said. No, in the accept call. Remember, accept call. It is a queue. This one. So there is a, when you say listen, you tell how many connection that I can accommodate at one particular point of time, and then in accept I keep getting the connection, keep taking out from the connection queue and serving. Right? Is there any confusion here? Like when we are doing where I'm connecting to client code, server code? Tell me, because this is important. If you have confusion now, there will be a lot of confusion later, because we'll be going advanced from here.
Amit, just a quick question. I mean, what if you would want to use the server as a client at the same time?
No problem. We can do the same thing. So suppose you want to use as a client, right? So what will happen is the
Yeah.
same code what we are doing here. What you will do is create a socket, new socket, and do a connect. Which address I want to connect to and which port, and you will do a connect
Okay.
from there.
So there would be two file descriptors, one which would be using as the server
Yes.
and the other would be for the as a
Yes,
client.
yes.
Okay.
Yes, it's just a code, no? It's if you
Okay.
write this code, it will become a client.
Okay. But
Right.
would
So
it-
this can happen. Like suppose if you think about it, as a microservices implementation you have. So suppose one microservice is acting as a server. So client came and connected to this service. Now to respond to the service, it has to again connect to some other microservice to get data. So now for that point of time, this becomes a client and other microservice has become a server. So that can also happen, right? This is a valid case where one particular service has to become a server for other, but a client for other.
Yes.
Right?
Yes.
So that can happen.
Okay. Fair enough. Yeah. Thanks.
Right. So yeah.
I mean, another question on the chat. Can you say that?
Sorry, your voice is totally gone today.
I just posted HR. Yeah.
You can post it on the chat if you want.
Keep posted.
I posted. Yes.
Yeah. So I'm just moving ahead. So once my so everyone understand
Just a
when
minute.
my yeah.
So when connect is happening,
Mhm.
I mean, not the connect, when the accept is happening, a new socket is getting created, right? So each
You
new
are telling
socket
in this
is,
code.
yeah.
Okay.
So each new socket is created after the send of message is done, right? I mean, it's not like 10 new sockets of 10 clients aren't being created. Instead, a new socket will be created every time
Yeah.
is,
For
a
each
send is
client, a new
done.
socket will be created. For
Yeah,
each
for
client, a new
each
socket
client.
will be created.
Yeah. Yes, that is okay. So when will the client from the queue is popped out? Are they done parallelly?
So once
Parallelly,
accept
the
has
10
taken something from the
sockets.
queue, that is taken out of the queue. Now that new socket has been returned, right? Now
Okay,
it
so
has
once
given
the
space
new
for new
socket is
client to come in.
created, okay. So
Right.
parallelly we can make 10 new sockets, right? And then we can connect to the listening socket.
Sorry, come again.
So let's say there are 10 clients in the queue.
Suppose there are 10 clients in the so suppose 10 connections has come and those are all in queue.
Right, all are in the
Okay.
queue. So now we are
Okay.
doing an accept. So it
You will
creates
not be doing accept after that connection has come into the and accept has already been done. And
okay.
then so see whenever you do a client server protocol, you whenever you do it, you will always see that server you have to make it up first. Like server that has to be up first before the client can send any connection. So suppose if you start your TCP client and server is not already up, client will just automatically return quickly saying that there is no server, no client disconnected, right? Because till that time server is not there to accept. So before any client can even connect, server should be up and it should be waiting at this particular API.
Right. So all the clients which are waiting in the queue are the clients which are already connected to the server, is it?
Yeah, correct.
Okay.
So see, I'll tell you what will happen. Let me finish this client first, and then I'll tell you what will happen.
Sure. Yeah.
So first understand when this connect will return. Connect will return when the client has already connected to the server, and it has gone to that server wala queue, right? It means TCP handshake has taken successfully.
Okay, now I got it. Yeah.
Right. So now what we can
Right.
do is now from here on you have your own business logic. Now suppose once it is connected, I want to use this particular socket to send and receive to that server, right? So now what I'm doing is I'm creating some buffer, so with some data, right? And I'm telling send, the same send what I'm using from this. It from this on, send and receive are all same. Even on the server side, receiver side, it's all same API. So I'm sending it to the server, this particular send. And if it is sent, everything is same now. What is happening inside? If it is sent, I'm sending it and I'm receiving this as a echo receive. This is something business logic that I have written, send and receive. And once I'm sent and receive, I'm just closing the connection. Once you close the connection, means doing this close client socket, it will remove all those, clear out all those buffers and all. It will clean everything, whatever was associated with this particular socket.
One
Right?
question, Amit.
Hmm.
For a particular query, we have to get a particular response, right? So in send and receive mechanism, how do you make sure that
You
like
have to write your own business logic.
no here when okay, when you say receive API and you get a response, is it like you get the response for what you queried for? Like
What you queried for means what? What is the
like
what you queried?
you are sending out a HTTPS query and you will get a response for that, right?
Okay, first of all, take that HTTPS out of the question. We are not even reached the HTTPS level. We
Okay.
think of it is key. We are just sending some buffer data like hello, hi, that we can directly send. HTTP is something that is a protocol which is written above TCP. So when we are doing some HTTP request, there are a lot of data that goes from client to server like that. So first of all, remove that thing from your head, HTTP and HTTPS. Those are application layer protocols that we'll see next week and how to write it. But right now, just think about we are just above the TCP layer and we have to suppose say simple hello. How do we send? And suppose somebody is sending hi, how do we receive? That's it.
Okay, sure.
So forget HTTP and HTTPS right now. Right?
I think is the Abid, I mean, it will just, the client is sending, hi, how are you doing? And server is saying, I'm doing good, something like that. So that what you are talking about is like an HTTP web client, which will be your browser, and then there'll be a web.
So that's what I'm saying. Forget about that. Those are protocols that we'll try to implement next week, which is again nothing but some data above the TCP, right? So like how we are sending hi, we'll be sending a lot of things to send hi. Like we'll be sending a proper protocol, HTTP. First we'll write HTTP 1.0, then /r/n, then we'll write content header, then we'll write the actual content, and then these many data will send. Then it becomes actual HTTP request. And from the server side, how will send response back? We'll say HTTP response okay /r/n, like that, then becomes a HTTP response. Right? So this is written on top of this TCP layer. And we'll use this particular logic to write HTTP client and HTTP servers. Right? It will become clear next weekend, but at this point of time, you only focus on how to send data to a server, how to receive data from a server, or how to send from a client, or how to receive from a client. Only these things. Simple data that you have to send to other end, and simple data that you have received from other end. How can we build a HTTP protocol server on top of this TCP? Also, I connect to HTTP server on port 80 using only TCP socket. So I need to use HTTP protocol. Okay, Sanath has asked a question. How can we build a HTTP protocol? That I will show you how to build. But giving a short answer, if you just Google what does a HTTP request and response looks like, you will see a lot of text that happens in a particular order that you can just write as a business logic. And if you are saying, can I connect to HTTP server on port ST using only TCP socket? Yes, you can. You can connect. But whatever the HTTP server that is on the other side, that will not respond thinking that it is not a proper HTTP request. Are you getting the point? Because it will try to because it is a HTTP server, it will accept only particular kind of text put in particular order. If you just send hello, HTTP server will not recognize as a proper HTTP request. But if the question is just if I can connect, yes, you can connect.
Amit.
Yeah.
Yeah, Amit, I have a faint remembrance of seeing some code of host to network and network to host. That is in case of Little Indian server sending, Big Indian server client sending. So that is done in receive or before that?
No, that is done on both the sides. So what happens is, as a system, whatever the system is, every system could be a different kind of architecture. So suppose your system could be doing things in big Indian architecture. right? Your CPU supports big Indian. My CPU supports, let's say, small Indian architecture. So does everyone understand big Indian, small Indian, what it is, or do I need to get into that?
Sorry, what is, what is little, I think it's got to do with some most significant bit and LSB or something.
Yeah. So suppose you have an integer, right? So listen everyone carefully, whoever doesn't understand big Indian and little Indian. So suppose you have a integer, which is mostly a 4 bytes, right? In a system. Integer is a 4 bytes, right? Yeah. So your memory address, how it is, suppose you have a memory address of 0x1001 for the sake of example. Suppose 1001, 1002, 1003, 1004, like that, right? So how do those integer will be represented in the memory will be either it could be, so suppose your integer is suppose 10. So in 32 bits, which is 4 bytes, how it can be represented 0000 something with the 10 in binary number, right? So first 4 bit will go to memory address 1004, or first 4 bits will go to 100, will depend on whether it is a big Indian or a small Indian architecture. Getting my point? So if it is a big Indian, in big Indian, I think most significant bit is at the lowest. So 100 memory address will hold the most significant bit, which is the leftmost bit when you convert it into a binary. So 000 will be 100 memory address, and the last of 4 will be under the 1004. So this is big Indian. So opposite of that is small Indian, right? So your system could be in small Indian. So depends on the CPU. So suppose your CPU is suppose with the AMD, my CPU is from Intel, right? So it could be supporting a different kind of architecture, our memory, right? So now when I'm sending a data to your side, suppose I'm sending 20 integer 20 that I want to send to your side, suppose, right? So if I send 20, which is on my system, suppose it is a small Indian, so it will go like suppose 100 and some in, so think of it like most significant byte was on this side and least significant byte was on this side. And when it goes to your system, it will read, if it reads like this, that 20 will become something else if it is reversed, right? In the binary. So what will happen to avoid such confusion? What we do is when we are sending something on the network, we change it to big Indian, and there are some API that is given, which is called something like this. So there is something called host to network like this, and there are something called host to network short or host to network long like this. And whatever you give inside, suppose I give 20, so that 20 will be converted to whatever the host Indianness you have to big Indian, because we are converting from host to network. Now when it reaches the other system, what you will do is do opposite of it. So you will do what? Network to host, like this. So what will happen is whatever the data I'm getting, I'll just convert it to my host system. Like if my host system is in small, it will convert to small. If it is big, it will convert to big. So there is no confusion after all. This is what happens: network to host, host to network, and you see this you getting used. So if I see here, no, it might be used here. See this? Can you see this? So when I'm choosing to put server port, which is 8080 integer, I'm first converting it to host to network, because it will be going into the other end, and I'm not sure what kind of Indianness it will be supporting the other system. So this is mandatory to use this particular API, and it will take care of everything. So this is that concept. Is this clear?
Yeah, one couple of questions. This is also a little Indian, big Indian is also at byte level. Means in a byte there are 8 bits. So the order of bytes is always constant. That is
that is constant. It's
always
just the
constant.
memory location. Yeah. 8 bits
Right.
memory locations. One
Okay.
byte memory location.
So this problem will not happen in the
character,
string.
it will not happen.
Okay, right. Okay.
Character, it will not happen. Whoever is taking more than 1 byte, no, it will happen.
Okay, and buffer is char only, a series of chars.
If you see here, whenever I'm sending a buffer, did you see anywhere I'm changing host to network or network to host, right? You will not see it. Whenever I'm changing sending integer, no, like this server port, there I am using this API. Because
Correct.
for integer, it is taking 4 bytes, and I'm not sure what other system will be storing it in, whether it will be a big Indian or small Indian.
Yeah, that's why I said that I had a faint remembrance of this API getting used, but I was not sure where exactly. Now it got cleared.
Yeah. So, okay. So from this point at till what we have done is client and server code completely clear. Like whatever code you have seen, connect, send, receive. So let's do this properly from the client side. Quickly, I will go through the step. Create a socket, assign whatever the address you want to connect to and the port here. Convert it that into the binary format. This is needed, and then you do a connect. Once connect has happened and it has come out of this API call, you can do send and receive. And once you think your send and receive is done, you can just close the connection. This is from the client side. From the server side, what you have to do, you have to create a socket, which is the listening socket first. This is the listening socket. And then you have to assign which all addresses I am listening to and which port. So this is that. And then what you do is you bind the socket with the address, right? Once you have done bind, you say listen, which is like passively saying now I'm ready. And here it is the active listen, like I'm ready to accept. Whenever it comes out of this API call, it means somebody has connected and you are giving a new socket to that particular client, and you can do receive and send on that particular client. And once you are done, you can close, right? Close the socket. And if I'm done with the server totally, I can close the listening socket also. So this is how the steps look like in the uh, server side and the client side. Now,
Uh,
now,
I just
yeah.
have one follow-on question to what Mithun was pointing out, right? So this is a text-based server, and let's say that I want to write a slightly more, sophisticated, let's say, image server, like, which is transmitting
Same.
images.
Same.
So even for sending out the image, therefore, I would need, because a image consists of pixels, and each pixel is a triple of
But
integers.
I'm
So I will
telling you
have to
it's
use
same.
HTONS.
No. I'm telling you it's same only, right? Even if it is a text, suppose suppose that it is a image. At the end, image is what? It's a binary data, right?
Okay, so
Yeah,
you're
it's a
saying
binary
the
data and
image
it's nothing
data
but a
is sent
buffer.
out as
That's
text.
sorry.
I mean, are you saying the image data is transmitted as textual data? Is what you're saying?
Don't directly say text. Say you are sending it as a buffer, stream of buffers.
Right.
001
As
and it
characters.
has characters,
As
one byte.
characters. Okay.
One
Yeah.
byte. That's why that
Only
problem
thing
will
is,
not arise.
only thing is, see, suppose I am sending hello or hi. At the other end, what will happen is it will, if I am taking it out in a string, right? Are you getting my point? If I am taking the hello on the other side, suppose in this main, in main, if I am receiving here at this particular point of time, in the buffer, if I have sent from the client, I've sent hello. In the buffer, I'll receive hello, and if you print it, it will show it as hello, right? But suppose it's some binary data you have sent from the client side, and it's nothing but a buffer only. What will happen is, suppose you want to send an image from one client to the server. Suppose, how will you send? You will open a file using that file wala syntax, file open or f stream open in the binary mode. It will give you the data, right? And you will keep sending it to the server, and you will keep receiving it in the buffer, same. But only thing is, if you try to print it, you will see some random characters of 88 bytes. You will not recognize it as characters, because
I
it's some
see.
binary data. So that's what I'm saying. There is no difference, even if it is binary data, video, image. These are all at the end just buffers, right? So you can use the same concept to transmit image files, video files, everything, right? That's why learning this TCP socket, TCP, no, it is very important. This is very important. If you understand this, what is happening here, now everything is business logic after that. Everything is business logic, right? Okay. Now moving on. So right now you can see this server, right? Now, can someone point out what is the problem that will happen at this server? Like suppose if I run this server and take it to production, what are all the problems that is there in this particular server right now?
Only one client and one message.
One client, one
Hmm.
message. Yeah. One
Correct.
request response. That's it.
Yeah, and why is that? Let's see. So suppose on client side I said connect. This is the connect. Whenever someone is saying connect, it will be it will come on accept. Connect might have gone into the queue or it has come into the accept. I have received a new connection. I did send and receive, and then what I'm doing, I'm closing the connection. That's it. Whenever now the new client comes, my server has ended, right? My process has ended. It will just see ki there is no server like that. It will give error. Is this clear to everyone? That this is the problem right now in this server? It will just accept one connection and it will end. That's it. So what we can do to make it so whenever you are talking about server, it has to be ever running, right? It has to be always ready to serve the clients, right? Until unless some error occurs, it should not close. So what we can do is this particular accept call. Whenever I have to take out a new connection, I have to take a new socket that I want to connect to, means that I want to send and receive. This the call should always come back here in the accept. These all remain same. These are, once it is done, listen, I don't want to call this API again. These are all done. But whenever I want to take a new connection, new client I want to serve, the call should come back to accept. Otherwise, I will not be able to take out connection, new connection. So what should we do? We should put it inside while loop, right? And these all code can go inside that. Now I'll see slowly we'll be building up a proper server, right? So now what problem did we solve? So what will happen now is accept call is there. Whenever somebody did connect, I will take out the new connection. I will do a receive and send, and I am closing that new connection. Because it is a while loop, it will again come here and it will again go to accept. If a new connection is there, again in a new socket will be called, and then I can do a send and receive again. So I can keep serving infinitely, right? My server will never end. Correct? Correct. So one thing was this backlog, right? Suppose my backlog is suppose 10, right? And till the moment I'm doing this except, so suppose except happened and some client I'm connected to, new socket will give, and suppose receive call I'm waiting. So that guy on the client side didn't send anything. So I'm just waiting on the receive call. This is a blocking call, remember, right? So I will never be able to receive, come to the accept because this my thread is getting blocked there. So when whatever the connection that is coming to the server, till 10 it will accept and it will keep in the queue. From 11th it will not serve. It will say connection timeout or error on the client side, right? So there is still a problem in our server, right? If some client connects but did not send anything, my receive will keep on blocking and it will never come to the accept. So what should we do?
I mean, one solution could be to spawn off a new thread, and in this new thread, basically that will be performing the work of receive and send
Correct.
in a loop, maybe. Yeah.
Okay. So what he's suggesting is instead of blocking this particular thread in the doing receive, or suppose client is sending also. Suppose we have a good client, he is sending also. But what if it is slow, right? Till the time I'm doing send receive, 100 request came. So because my backlog is 10 only, from 11 to 100 all requests will be dropped, right? So in that case, what we should do is the moment we do accept new socket came, let us do the send and receive in a separate thread, and quickly let's just come to accept so that we can accept a new connection. Is this clear? Right. So what we can do here is after connection has been accepted, we'll just say simple thread. Let's include thread. Right. And from here, after connection has been accepted, what I can do is thread Let's call it T, suppose. And we need to have some starter function, right? We can also give a lambda, or you can also give some separate function to handle it, right? What do you want? You want a lambda or a separate function? Let's give a separate function to handle it. Let's say handle clients. And let's give it a socket. The socket on which I have to do a receive and send. Simple. And let's take this whole thing inside this thread. And in thread, what we'll do is we'll say handle clients. This one. And what does parameter it takes? Socket. Which socket? The new socket. This one. On which I'll do the send and receive. Right? Now what else? Tell me. What is still wrong with this? Should I do t dot join or not do t dot? Because we know from the multi-threading, right? We have to either do
T dot detach.
T dot detach.
Yeah.
Why T dot detach?
Because we want to disassociate.
Yeah, we won't be able to accept new connections if we don't detach from that.
Yeah. So first thing is, why not T dot join? Because if you do T dot join, until unless this thread is done with their work, it will not move it from here, right? Remember, join is a waiting call. Until the thread has completed, it will not move away from T dot join. So this is a very good case to use T dot detach. Why? Because we know this is a forever running while loop. My main thread will never gonna stop. So it makes sense ki just this thread will detach and it will do its work and it will end whenever it has to end. So very good use case for using T dot detach. Does everyone get this?
Amit, I have one small doubt. I think Y2 detach, I think even we don't detach, right? Still it works, right?
No, if you don't detach,
No,
it
it
will give you
crashes,
error.
I think.
It crashes. You have to give detach or join anyone.
No, I will keep the vector of the threads in a global space. I will push back this thread into that global vector. So the thread will have scope. It won't crash, right? At that time, still it
No,
serves
but
the.
at some point of time, you have to give join or detach somewhere. Otherwise, if you sit, it will crash. The program will
Yes,
crash.
whenever the server dot close, we will do, right? At the code, at that time, I can join all the threads, whatever the clients that I have.
But think about it. Why do you want to keep your thread waiting to join there? Suppose what you are saying is after this while loop, right? You are trying to join,
Yes, before just
right?
closing. Yeah.
You are saying that let's join it here, right?
Yes.
But what will happen is one thing is this will happen properly. So suppose you are going to accept call, but till that time, think of it ki all the threads are waiting here.
Yeah, but detach
Wait.
also it will wait, right? In the OS.
Why? Huh?
In the detach also we are saying that we are detaching from the main thread. Let them do their own work, right? We are not at all tracking those threads. If we detach like that, it will complicate our server, right? We don't
Why?
know.
It is that's what I'm saying. Joining will become a more complex. Detaching it is simpler here. So now if you detach here, you don't have to think about that thread now. Because why do you want to think about that thread? Think of it. Like that thread is now taking care of send and receive for a particular client. And whenever does that happen, it is that responsibility of that thread. Whenever it ends and does not end, it's that responsibility. My main thread is now doing its work. Why should my main thread is now keep on looking when do I have to detach and when do I have to join? Does it? It's, logically it makes sense for me to detach. What does everyone think?
Yeah, in Hindi we say, right, मेरा उसका कोई लेना देना नहीं है. Detach is like that.
Yeah, I mean, see, whatever you are saying to you put it inside a vector and then do all the join here. So suppose thousand clients come and then there are 1,000 threads and then you are doing a join on all the 1,000 threads,
Got
right?
it. I got your point, Amit.
Right. But think about it. We know that this is an ever running loop, right? This is never gonna end. It is only gonna end when the server has to close. In that point of time, anyway, my thread has to be closed, right?
Yeah, Amit, but I still see one more issue with this code. In the handle clients, you have closed the connection. What if the client wants to keep an open connection?
Then you will not write this. That is business logic.
Okay.
When you want to close is your logic, right? It can be like this that you want to put in this like this.
Right. But then if client is not written close socket, then it will going to wait timeout state in
If
TCP, like,
client has
because they
not
have to
written,
also close, right?
yes, yes. So
To
once only
disconnection.
they have closed, then only we'll be able to see ki if in receive what we have received. We'll go into that later. Ki if
Okay.
receive receives a 0, no, it means that from the client side we have received a close. So in this
Okay.
API, we have to check
Right.
actually.
I see.
I have
I
not
see.
written
I
a
see.
proper code till now. So
Okay. Okay.
if receive val read is equal to 0, exactly equal to 0, it means client has closed the connection. So in that case, what you can do is you can actually break, and then at the end you can do a closed socket. So this how your code should look like if you want to continuously read and write with the client. So in the while loop, you will be doing read and write, read and write. And once you see if while receiving my value read has become 0, it means that client has sent a close connection, close socket from their side. So it will return 0. In that case, I'll break and I'll close the socket and my thread will end.
And if the server wants to deliberately close the connection after sending the reply, then also client also will have to write the same code. Like it will get a 0 and it. Okay.
Yes, yes. So if suppose if I after sending, if I do a close socket here, so close of new socket. So in their side, if they are receiving, they will receive a 0. And then they have to check
Got
if it
it.
is 0, then server has disconnected. Correct? Okay.
Amit, there is, I think I saw that there was one more problem if we do this t dot join outside that while. So another thing could be like, the server process will keep on growing in size until all the clients will be done, right? Because
yes. So okay. So now what server right now we have is it is always running server, and my each client is getting served by a separate thread. Is this clear to everyone? This code right now. My each client is getting served by a separate thread. And once it is done, that thread will get stopped basically. This is done, though, so that thread will be cleaned. Is this clear till now? Like any confusion till here? No, right? Shall we move ahead? Okay. So now tell me what is still there is a problem with our server. What problem does our server have now?
Thread pool.
So what is the problem?
You don't have control on how many threads will be spawned.
Yeah. So
Or you
suppose
do.
I've
Or you
created this
do.
server, and suppose thousand clients came to connect to me. So I will be creating how many threads? 1,000 threads. 10,000 threads if 10,000 clients are there. So suppose all the clients are busy doing send receive, send receive, send receive. No thread is getting deleted or means over with their work. So in that case, my thread will keep on growing as per the number of clients is coming, right? So that is the problem if I have to actually in the real systems, right? It can happen that you have 10,000 or 1 lakh clients connected parallelly to your servers, right? It can happen. So you will have, if 1 lakh, then 1 lakh threads you are creating here, right? And it will choke your system. Your system will die. Your server will crash. Correct? So what is the solution that we can think of? Instead of creating each thread for a particular client, what we can think? As Mithun said, we can use thread pool. Right? So what is the because I have not taken a thread pool class. So can anyone tell what is thread pool and when do we use it? I've asked everyone to look at the video that I have done on YouTube. Can anyone quickly tell me what is thread pool and what problem does it solve? Anyone?
I can try if nobody else wants to volunteer.
Yeah.
So thread pool is where you limit the number of threads spawned by the system. And how you have explained in the video is that we create a producer consumer kind of thing, and the producer will produce the task and the consumer will start consuming it.
So basically thread pool is something like when the system is initializing, at that particular point of time only we'll create some amount of threads. Pre-create, just like Ramai saying, we pre-create the list of threads, right? And suppose we'll check what is our hardware concurrency and all. Those are like algorithm, how many threads what we want to create. So suppose we create 8 threads. Suppose. So we'll create threads even before we have started accepting and started doing all these things, right? And we'll use only these 8 threads to assign our work, to actually handle the clients, right?
But there is
Instead of creating thread per client. So each thread, suppose this client came, one thread from the thread pool will be assigned to do his task. Once that is done, other thread will come and do its task. Once this is done, it will take up another task from the thread pool. So there will be only 8 threads that will ever be on your system. So it might lessen your throughput, because now you are not serving each thread per client, but it will keep your thread to a minimum and your number of parallel connections will increase. You will be able to serve more number of parallel connections, but your throughput can become little less. But you will be sure that your system will not get choked.
no,
Are
but
you getting the point?
but there is a problem, right? Like after 8 clients, the 9th client won't be served at all.
Why?
It will, because the accept, right? The accept call will go through. So you might have 1 billion clients. So 1 billion new sockets are then created, but you don't spawn off a thread for each one, but instead use a thread pool. I think that's what Amit is trying to say, right?
Right,
Yes.
right. But see, handle clients is a while forever loop, so it will not come out. So if 8 clients will be continuously handled in a forever loop, so 9th client will be starved. That's what I can think of now.
So
I mean,
I'm coming back to the problem. So I can
Okay.
use a thread pool. Let's see how we can use a thread pool right now. So what I can do is I have some, if I see here, thread pool. So one library I've seen on internet, which is good thread pool library, that you can use to write your, either you can copy the code whatever I have given, or you can use this particular thread pool. If I am not wrong, 1 second. What is that? CTPL. Yeah, this one. So this is the thread pool library written in, this is open source, written in CPP, that you can use in your code, and it is very simple to use. You just have to download this particular file, ctpl_stl.h. Use this file and put it in your source code, and then you can use the API that is given in the this particular library. If you see the code also, no, the code will look more or less similar to whatever the code I have given in the YouTube, and that code I'll give you next week also in the notes. So if you see the thread pool, no, it will, if you have gone through the YouTube video, it will, the code will look more or less very similar. So directly, either you take the code from here, you write your own thread pool, or you can, if you don't want to go ahead with that, you can directly download this particular file, .h file, and you can use to create thread pool in your code, right?
Any copyright?
No copyright, nothing. You can see there is star mark of 1.8K also. So I think you can use this.
Okay.
Good enough. Huh? And very simple to use, because it's just a header library that you have to use. No lib or DLL or anything. Directly download and put it in your code and you can use it. So, so how can we use that thread pool? So I have that code somewhere, I think. In 1 second. Thread pool. Prepare and send.
Can't you use any parallel calls? Like last time you spoke about it, that you will be covering it, parallel functions.
Which parallel calls? Oh, parallel algorithms.
Parallel algorithm.
See, internally, then again, that will be calling the thread only. No, it will be creating a new thread, right? So I don't see how that will help.
No, that will only help because at least you will still be using standard library rather than some external
So that's
even.
why, Yeah, that's why I have given this this particular HTL, because that code is using HTL, so that will be standard. So you don't have to change the code for Linux or Windows; it will remain same, right? It
But
is
there I saw
portable code.
Boost also. Is it using Boost?
So if you download the other one, it is implemented using Boost, and then there is one implemented using HTL. So you can
Okay,
use HTL wala
got it.
one.
Got
And
it.
why I am
Okay.
using that? Because the code will be portable. It will work both on your Windows and Linux both.
Okay.
So no need to write separate code for Linux and Windows, at least for that particular thread pool. है ना? So where is that code? 1 second. Thread pool. Huh. So you can use it like this. So instead of doing this particular thing, I can do this. So this thread pool and so this one. And this is the include file that you have to include. So once you download that particular header file, you can include like this. This is the same file, ctpl_htl, right? I've showed you, right? So once you have in your source file, you can include this, and then you can use the thread pool like this. So it has API like this, thread pool dot push, and this is the function. And what we are giving is we don't need this right now. So we'll capture whatever the socket that you want to pass to that new function. So this is our new socket. And then it will take this int thread as parameter that you have to give. This is the requirement of this API. And then from here, you can call this particular handle client wala function. This handle clients. And you can pass new socket. So now instead of creating thread per client, now we are just pushing it to the thread pool. And how do you have to initialize it is, you will have to initialize with some threads, right? Like we said, you have to pre-create the threads. So you can create it like this. So while before starting only at the very start, you can put the code somewhere here like this. So thread pool, something like this, whatever you want to say. So you can remove this. So thread pool. And this is the code I've written to determine how many threads I should need to write. You can give whatever the number, or you can write a function to check how, whatever the hardware concurrency you have, the number of cores you have, then that you can pass it in here, right? So whatever, like if suppose I want to create a thread pool with 8, yeah, that you can pass it here. So now it is when this thread pool will be initialized with 8 threads. So instead of it, you can determine the number of cores, and that you can pass it in here. That is clear, right? Okay. So now what we have done here is, instead of creating a thread per client, what we are doing is using thread pool to serve my functions, serve my client. So what will happen is, whenever a new client is coming, so now let's see from here, whenever a new client comes, except will return, it will take a new socket, and then I'm calling this particular, giving this thread pool this particular function with this new socket. And in this, what we are doing, we are serving that client, right? Now, what is still the problem with our code?
I think buffer is a shared variable, and I don't think we took care of that, right?
Correct. That is also a
Our
problem
code
here.
is
So
not like
this,
thread safe.
correct, exactly. So this buffer, if you see here, right now, so don't have buffer. So we actually, this buffer, no, you can directly create in here. So char star buffer is equal to whatever you want to put here, like hello or something, whatever you want to send. And then that buffer you can use instead of using this buffer now, whatever we are using earlier.
Yeah.
Right? This we can delete from here. So now every client has its own data to what they want to send. Right? So you are right. Earlier it was a problem. That was a shared buffer. So now that is gone, right? So that you can, inside each client, you can decide what to send, what to receive, depending on your algorithm. Okay. So now what is still the problem with our code? with our server?
As I said before, like this, if this connection is going to remain open, for example, then we will only serving 8 clients, and the 9th client will be starving.
Yeah, correct. So what will happen is, see everyone, what is the still the problem with our code? So suppose one client came, my thread pool, I'll push that to our new our thread pool, and this one thread from our thread pool will start serving this, will start going through this code, right? So suppose what happens is, can you see, well, we have done a while loop, right? And inside this it will keep in revolving until we are done with the send and receive. So even if it is not there, just think about this. So we are waiting for the receive, and receive is a blocking call, right? So until someone sends it, or even if it is slow, this particular thing is dependent on how slow it is, or when client is sending, right? This particular call, or even this particular call, if you are lot of send to happen in other threads also, so these things can become slow, right, in one thread. So what will happen is, suppose one of the thread is still occupied in doing this, serving one client. So similarly, suppose 10 clients came and it is serving 8, suppose we have created 8 threads. So till 8 threads will be serving, each thread is getting served by each client. Each client is getting served by each thread, right? When the 9th client comes, all the threads are occupied, right? So this thread dot push, what we have done, it is go inside the queue of the thread pool, but still it is not getting served. Are you getting the point? 8 threads are occupied in serving the 8 clients. While the 9 client has come, we have pushed into the thread pool ka queue, but this will not be picked up by the thread pool because all threads are busy, right? So this, until and unless this thread is done with this, it will not be able to take the other client. So suppose all the 8 clients which my thread pool is serving is taking some time, or it is doing send and receive a lot of time, and it is taking time and it is not ending. So from my 9 client, it will never get served. Then what is the point of having thread pool, right? So this is the problem with our code till now. Does everyone get this problem, right? Okay, so how to solve this? Problem is where exactly the crux of our problem right now? It's because of this receive and because of this send. My receive and send are blocked is my problem. It is the crux of our problem. If suppose by somehow, if I'm not receiving anything, if my thread becomes free and try to serve other client, then our problem is solved, right?
No, but still we are in the while loop, no? While one.
While loop is there, but if it is suppose
I mean, we can
if it is
redesign, we can write whatever logic we want. So it's like I want that thread to switch to
suppose
another
this while
client.
loop is not there.
Then okay.
So do you get my problem is with this particular API call, right?
But Amit,
because it gets blocked.
Yeah, but
tell me.
Amit, let's say with Amazon.com, so it doesn't know how long the customer is going to be on their website, right? So in such situations, yeah.
So in such situation, first of all, if you see the HTTP request, no, when we'll be doing HTTP request, you will see HTTP requests are stateless protocol. If you learn this, so what will happen is HTTP requests get sent, it will send the response back and it will cut the connection.
Yeah, they are not persistent.
They are not persistent until unless they send in request, they send a keep alive alert.
That Kirti had explained after 1.1, it is persistent now.
But you have to send a keep
1.
alive connection.
Okay.
Right. So if you see a general HTTP request, how it happens, you send a request, it sends a response and cuts the connection. Like cuts the connection means what? Close the socket. Close the socket.
Okay.
So my thread is free, right?
Yeah. Then free.
Right. Correct. So how do we solve now this particular bottleneck that we have in receive and send? This is our problem, that our receive and send can get blocked. Can we send an array of sockets to that handle clients, and then if val read equal to 0, then try receiving on the next socket and so on? Try receiving on next socket. Why do we want to do that? If it is 0, then anyway my client is closed. I will close the client and my thread is free. So it will serve other client. Right. So the problem what we have to solve is if somebody is stopped on receive.
Can you
Yes.
set
Okay.
some timeout?
So there are few things that we can use. So one thing we can do is we can have an algorithm saying, suppose if my client has not sent me, suppose in till 5 seconds, my client has not sent me anything or 2 minutes, whatever it is. One thing is I can put a timeout. If I don't receive in 2 minutes anything, I will just return from this call. I can put a timeout on this receive. Right? That is one thing. The other thing that we can think of is if by some way, if I have some way, instead of waiting for the receive to happen. So remember what I told in receive. Receive will be blocked until some data in the kernel buffer has come. Once data is in the kernel buffer, it will be copied to my buffer and it will return. But the problem with receive is it will wait until there is some data in the kernel buffer. Right? So what if I do a receive and if there is no data in the buffer, I just return and someone else tell me afterwards, oh, okay, now data has come, now you can do a receive again. Won't this be a good idea? Like then my thread will be unlocked and it can serve other customers, other clients, right? Then there comes the concept of IO multiplexing and ePOL that we'll talk from tomorrow, right?
Okay.
So this is like a polling mechanism or ePOL that we'll use. First we'll in theory we'll see what is select, then we'll see what is poll, and then we'll try to implement ePOL.
So
We'll
receive
not
does not have a receive async where you pass a callback function and that will get called.
No, not like that. No.
Okay.
That as an algorithm you can write for someone. You can give an API to someone that you can give your callback function, and if something get received, I will call your callback function.
Okay.
But here, what polling mechanism does is the same thing. Once receive will not have any data in the buffer, it will quickly return. It won't even stop there. Right. And then there will have mechanism of ePOL and polling and select, where our OS kernel will tell ki now you have some data that you can receive. Now at that point of time, we'll do again the receive call. Because now we are sure that some data is there that we can take. Till that time, our thread is free to serve other clients. Right.
Are
That
you
will
saying that in the next session, so we won't be using RECV, receive API, receive OS call? I mean, some other call
we'll be
using.
using receive only, but we'll set it to
Oh,
non-blocking. Then the concept of non-blocking will come. Right
I
now,
see.
all
There
these
is some
calls are
parameter.
blocking. We'll set a parameter and we'll make it non-blocking. So if it has data, it will come with the data. If it doesn't have the data, it will quickly come back saying that I don't have data right now. I might come back later. And that you have to take care as a code that you have to write something. And let's start fresh from tomorrow, because what I want is everyone to write at least this till here, till this one, thread pool. Till thread pool, I want everyone to write a server and a client, and let's try to connect each other. Both the thing.
Yeah.
That's why I'm stopping it here. Right. And fresh will look it, because if you have not written this code, not understood till here properly, ePOL will again become difficult, because we will have to write a lot of code from our side to handle such things. So this concept, whatever we have done till today, should be very, very clear. What is happening, what happens when close is coming, what happens when receive is 0, what happens when my receive buffer is low and my receive is greater than my receive buffer, what will happen. So those things that you need to check, quick things, check what happens in this case. So please, whatever the code you can see here, you can try to write a simple TCP client and start from there. Write a simple TCP client, simple TCP server, connect, done. Then go ahead and make it inside a while loop, keep it a ever running server. Once that is happening properly, done. Then go to one thread per client, see if it is running, then done. Then go to thread pool. Do it like this, how we have done today. Then you will understand what problem we are solving in each step. Right. And one more thing that you can do is you can install Postman So what we'll do, so this is Postman. You can install this and you can create a collection from here, I think. Where do we create a collection? So this is a collection. If you add plus sign no here, you can create a new collection that I have created, server test. Inside server test, once you create the connection, you can create a new from here. From here, or even you can create from here, I think, add request, right? So this request I have added, and here I'm trying to connect to my server. So this is the server, AWS server, that my AWS Linux is running, and I have created a server which is running on 8080. And when I click send, it should give you a response, whatever your server will be responding. And why am you trying to use this is, if you go here to the collection and you do a right click and do a run collection and go to this tab performance, and then you can choose here, do you want to virtualize 20 users or directly connect 100 users? That you can directly change from here. So suppose I want to take as 100 user, and how many tests 1 minute I want to run, and then you start running. So it will show you how fast is your server right now. So it will give you request per second it is trying to serve, and error rate and everything it will give after you have run. So please try this after writing every server. Like once you have written ever running server, no, you can start trying how much throughput your server is giving, request per second, right? You can use it using this Postman performance test. And then once we are building up, we'll see is my performance increasing or not, is my performance increasing or not. We'll keep this as a metric.
But
Right?
Postman is only for HTTP, or we can do TCP request also.
So what will happen is, once you send a request, no, it will send as a HTTP request. From that side, what you do is you send a response as proper HTML response. So something like this. So what you do is you take a response like this, like I have given, no, you copy this, or you can
ये
even
कहाँ
search
से
on internet, give proper HTML response.
Okay.
Give HTTP response like this. And instead of just sending response as hello, hi, you can just copy this and send as a character buffer only. So is there any response? So see, the response is something like this. So give a proper, I'll say, okay, response example. So if I'm just randomly searching any HTTP response, or you can even put in on ChatGPT, give me proper HTTP response, and you can copy that. Let me see if I have that. I'll just copy it. So something like this. Not here. Okay.
We couldn't have done load test using Putty and Telnet.
Putty. Putty is to just you do SSH connection. How do you do load test?
No, I'm just asking that वहाँ पे भी if there is something that you can make Telnet connections.
But how will you run? If you can run this in a loop, that's fine. You can do it. But I'm trying to keep it as some standard
Right.
tool that we can use, so that we can keep checking our metrics. Is it better now or is it better now, like that?
Yeah, get this idea. Very good.
So if I send, so suppose instead of this buffer, what we can send here is like this HTTP response. So this is a proper HTTP response. If you send this, then Postman will be able to recognize it. Even if your Chrome will be able to recognize it, because this is in proper HTTP format, right?
Right.
So if instead of sending buffer here, I can send HTTP response directly. This one. So now in the send, what I'll do is I'll send this. That's it. It will give you a proper. If we'll send this response, all the Chrome or Postman will be able to recognize your response. Right?
Right.
Okay. So so now I'm ending the session for today. Tomorrow we'll start looking at multiplexing and ePOL techniques and all. And tomorrow, yeah, before writing the ePOL techniques, what I will do now from tomorrow is I'll create a proper folder structure and everything, and we'll write a proper project. So creating TCP server, and we'll try to write a portable code for Windows separate, for Linux separate. And so like if it take on Windows, it works, it take on Linux, it works. So why I want to do this is, you should know how to write a proper code in the which is portable, which is like you have to run a Windows server, you can do it properly, Windows client, or Linux server, Linux client. So I'll first, when I start the class, I'll go through a proper folder structure, what code where to write, what CMake list, and what code to use, and then we'll start writing. Then we'll write code till here, the thread pool code till here, and then after that we'll start building on epool. So that when we go next week, what will happen is, when we'll start writing HTTP server, we'll use our TCP server and TCP client to write our business logic on top of that, whatever we have written this week. Right? Getting my point? We'll write a TCP server properly this week, and from next weekend, we'll use our TCP server to write on top of that HTTP server. So please practice this today. If you have any confusion, anything, please put it out on Discord. Hardly like 3-4 people only use it, our Discord. Yeah. So any questions for today?
Will we also be able to see whether our server will eventually support millions of connections?
You can, but you will have to use the, so suppose I was using T2.micro, right? And it has just one core and 1 GB of CPU. Right. So
Okay.
whatever you do, it won't support. There is a system limit also. So if you want to support 1 million, or maybe if suppose you want to support throughput of let's say 1 lakh request or 60,000 requests, you have to need to have a 16 GB RAM, and suppose cores would be like 8 or 16 cores, like that. You need to have those machines. You cannot just expect your code to do all the thing, right?
Yeah,
So
but
there,
if not on cloud, if I have that machine, if I get from the company only such a server, then I can try it there.
you can try exactly. You
But
can
how will
see,
you test millions of connection using Postman again?
means I will not be able to show you millions of connection. I will only be able to show you that if writing this code has some metric, after writing this code, our throughput has increased. So
Okay.
yesterday I was trying this, and with the epool, I was trying to support around 50 requests per second on T2.micro.
Okay.
And without epool and all, it was around 14 requests per second for 1 minute. If you go beyond 1 hour, 2 hour, no, you will see more increase in request per second.
Okay. Okay.
Right. So T2.micro, so yesterday what I was doing is, I had written that code of getting the hardware concurrency, and then I using that hardware concurrency result to create that many threads in the thread pool, right? And then I was thinking, my speed is not increasing. Why? Then I realized, oh, it is T2.micro, and T2.micro has just one core. So it was returning me, concurrency was returning me one. So my thread pool has one thread. So it was not giving me proper result. So I changed that. So those things that you have to see. Okay, any questions from anyone?
Amit,
Amit,
how do I run this?
Sorry?
Yeah. How do I run this client.cpp? Just like after starting the server, should I run the client.cpp?
Means you have to write a separate project for client.cpp.
No. Like before coming to the tomorrow's class, like I was thinking to start the server, and for client, should I just give it from the postman, or should I run this one?
You should write at least once, the client also, so that you know how to write a client also, and try to connect
Okay.
to your server only.
Okay, then if I write this client, so after starting the server, I will run this client. Is
Yes.
it like that?
Yes. So you need to have a two separate executable that will be built. So one will be built using. So suppose this is one networking project. So make it as TCP server. It will have a separate CMake list, and the file will be this server.cpp file. And then we will have a separate project calling TCP client. And once both are built, both executable, first make up the server will be up, and from then client will be up, and then client will try to connect, which your code logic will try to connect to the server and do the echo response or whatever response you want. At least try to at least once write client and server both. Then after that you can try the Postman thing, or maybe Chrome also, that you can try.
Yeah, got it. Could you also share the client and server code in the chat?
Chat, can I send it on directly Discord
Yeah,
that
yeah,
you
sure.
can direct? Because
Whichever.
after I close it, chat will be closed.
Yeah, sure.
Yeah, I'll send. Okay. Any see, if today's class you should be fully convince yourself that you have understood today's class. Because if there is any confusion in today's class, there will be a lot and lot of confusion in coming classes. For sure, you will not be able to understand it. If you do not understand what is happening inside receive, when it is blocking, when it is non-blocking, when the accept connection is happening, why do you have to get to connection again? If those things are not clear, then you will have a lot of problems in coming classes.
Hey
Right?
Amit, one question, like
Hmm.
just can a program can a use can can a user process in running in the user address space, can you ever acquire a memory pointer to some variable in the kernel address space and manipulate it directly, or it's not allowed ever?
No, not allowed. Not allowed.
Okay.
Otherwise, it creates a problem.
Okay.
There are some ways. So, have you heard about this API called IO_Uring? Anyone has heard? IO_Uring. So actually, problem is that some hackers know when you see somebody is hacking any system or doing anything like that. Those are the people, they know how to get hold of your kernels and all. Get in. So the what you are asking, I
Oh,
am
okay.
not sure how to do that because mostly you will not be able to. But there could be some way. I am not sure right now how to do that. But I'll be teaching you IO_Uring. There is a API in Linux
Oh, okay.
which is very recent. It has come from kernel 5.1 or something, which you will not find it, and it has gained very much popularity in today's system. Like people are running behind this API because we'll study epoll, right? And you'll see epoll is serving a lot of purposes that we are facing problem right now. Epoll will do something better for us, but there was some problem with epoll also that I'll tell you when we'll do epoll, and you'll see how IO_ is using API is again doing better than epoll. So my earlier plan was not IO_Uring was not in my earlier plan that I'll take it, but I can see a lot of people talking about this API, new API, and people. So and this can be used not only for the sockets but for the file system and all also. So once you open a file, read a file, that those are also slow things, right? Slow processes. And IO_Uring APIs make it very fast. So I think it makes sense to cover that API, and that I will try to cover. Because you need to know what is happening recently in this space, right?
Yeah.
So I'll try to cover that.
But normally these device drivers and all, they write the kernel level calls, means current, they run in kernel level, right?
They run
So
in kernel level, right?
the
Oh,
device
device
driver.
driver programs, device drivers themselves run in kernel space.
Yeah.
Yes. So there is a way to get hold, but not directly. There has to be something else needs to be done. Not directly what we are writing code right now. That cannot go into kernel space and get hold of the buffer of a kernel and everything. Because
Yeah,
yeah,
I also don't
yes.
know.
ठीक है. We'll have a hacking class somewhere, then we'll try to read that. Okay.
You can take down these interesting things, right? Cyber security hai, hacking hai, right?
Even I have to be
As
confident in that to take the class. I have to hack few things to take the class. Okay.
Okay, one more thing. Like last time you had introduced some terms like latch and barrister and
Barrier.
barrier.
That is
Okay.
multi-threading. Yeah. That we didn't take because mostly people don't use it only. Those are not popular.
Okay,
Those
but
come in, those are synchronization mechanism while doing multi-threading.
but can you say similar to which one in Windows? Just कुछ idea है तो?
Windows means those are given in HTL, like proper HTL library, latch, and but people don't use it, so I didn't take it. And those are
But
just like synchronization mechanism only, just like lock or mutex. No, those are synchronization mechanisms.
because I have worked mostly on Windows and mutex is there in Windows, which is also here. Then semaphore is there here. Then you said this condition variable, which is called event objects in Windows.
Yeah.
So this barrier and latch would be, can you relate to something?
Very specific to Windows, not that, not I'm not sure what is
Okay.
very specific term for the Windows. That I don't know.
And in
Yeah.
Windows, there is something called interlocked increment. Is
Okay.
that related to atomic in CSTL?
I have not seen that.
No.
So
Okay.
mostly I try to keep whatever portable that we should write. We should
Yeah,
mostly
yeah.
try to write STL, but
Oh,
I
yeah,
understand
Mithun.
you might be using Windows specific API calls.
Mithun, that is correct actually. Interlocked increment is in Windows top
Atomic.
for the STD atomic.
Okay. Okay.
Yeah,
Right.
even me also. I only worked on the Windows, but I'm always regretting that I never worked on the Linux because no, in some of the very low level and all you can't do. It's like I always say maybe it's a little harsh. So that Windows guys are like toothless snakes. They don't have anything much about this one.
No
Everything
venom.
on this level.
No, I worked in the days of com and decom also. उसमें भी मैंने बहुत सिर खपाया है.
Yeah,
So,
yeah.
Okay.
okay.
Okay. If you're talking about Windows, there is a concept. So we'll be talking about ePOL and all. No? So with that reference, something came into my mind. So there is nothing called ePOL on Windows, right? So if you have to create some high-speed server for Windows, what concept do we use? You have idea, Mithun? Because you work on Windows mostly.
For the socket programming, I have used Select API.
So Select has a lot of with drawbacks, like it only supports 1024 sockets and all, not beyond that. Right.
Okay.
I'll tell you about the socket theory tomorrow also. So
Okay.
Select is something which is in both Linux and Windows
Right.
both. So, but ePOL is something different, and
Okay.
something is there on the Windows that people use
But
in
what is ePOL?
correspond.
If you tell me, maybe I can draw parallel.
And ePOL is something like, suppose it's kind of a notification mechanism. So suppose I will tell my socket, hey, you subscribe to this particular notification, and then OS will tell you, okay, this you can do this now. Now you are ready to do this. So that is given by select or ePOL everything.
Like a callback?
Not directly callback, but a notification is what I'm saying. Suppose suppose on socket I'm trying to read something, but that is not available. So what I'll try to do is I'll subscribe to that receive call. See, some buffer data come in that receive. OS will tell me, hey, some data is there, now you can receive. So notifying the user process.
So there is something called Windows hooks. For example, when you do a click or right click or something, so then the Windows you can hook that call and then you can get all the notifications. So that is one
So
one way.
yeah, so there is a concept called IOCP and overload.
IOCP.
Oh, yeah, and overlapped IO. So these two
Okay.
together.
Yeah,
So whenever you
overlapped I
see
heard.
this library, no, libuv library, which is very famous, which Node.js uses to create the servers. So
Okay.
that libuv library is written in CPP. So if you see, no, so libuv library internally uses ePOL on Linux, KQ on Mac, and then IOCP on Windows. So IOCP can be used for file systems also and sockets also. So
Right.
that creates a very good throughput that you can read IOCP.
Okay. Okay.
Amit, that is one WSA async select is there. Is that one you're
So
referring?
once you do once you are using IOCP calls, you cannot directly then use send and receive. You have to use WSA send, WSA receive, WSA accept, those calls. So there are two different calls in Windows. One is a blocking call, which is simple send receive, and then one is WSA send, one WSA receive, which are non-blocking calls.
Yes, yes.
So you have
WSA
to
is
use this
not.
together with IOCP. Okay, fine for today. Like tomorrow, we'll discuss some advanced things, ePOL and all. Okay, so no confusion for today. I think you should all write this once, and if you're having any confusion, you can put it on Discord. And please have, I'm expecting more participation on Discord. I'm like literally
Yeah.
seeing only 3-4 people only posting every time, even though we have like 70-80 people there, I think, on Discord. Let's see how many people we have. We have online 10s, so around 675 people we have, but I can only see 10 people or maybe 5 people only. Okay.
Amit,
ठीक
We'll
है?
try.
Amit, quick question before
Yeah.
we leave. Uh,
Yeah.
Just out of the, I mean, may not be related to the discussion that we had. How does messaging protocol work? I mean, underneath, does it also use the TCP raw sockets, or
Which
I mean,
messaging protocol? Which protocol?
maybe let's say for example, WhatsApp itself.
Acha. So
Yeah.
those WhatsApp and all, they will be using WebSockets, right? WebSocket protocol. And then
Okay.
WebSocket protocol itself is written above
TCP.
HTTP, and which is written above TCP.
Okay.
So
So it's
internally,
a
everything
layer.
is TCP.
Okay. So it's a layer
Yeah.
or a wrapper or a wrapper. Okay.
Yes.
Okay. So
All business logic
we,
written in particular order. So if
so
you
will
if you
we,
see no,
sorry.
if you want to see what happens in, so you just have to search RFC, and then if you suppose you want to see how HTTP protocol, you just type RFC HTTP. So this is the actual standard protocol that is given by IEEE standard and all. So RFC is request for comment, and then this will tell you exactly how the protocol should look like. So every one who creates the library, so suppose somebody is creating HTTP protocol, then they have to go through this and check, okay, if this thing happened, what I have to do. So and then they will use this to create the HTTP library. So suppose if I want to see, it will tell everything about HTTP. So what is request chain? Rule one rule. So this will tell you everything about this protocol, how you should implement it. And so CRLF is actually CR and control return and line feed. So I wanted to show you. So basically, if you have to properly implement, you will have to go through this RFC document to create your own HTTP library. So similarly, if you want to see WebSocket, you can just type RFC WebSocket, and it will give you everything about that there is to about the WebSocket protocol. How you should what it is, how you should send data, how you should receive data, everything. What is ping, what is pong? In WebSocket, there is a concept called ping pong that happens. So how you should implement, what should happen, how much time it should wait. So everything is written here, and then you have to see, and then you have to implement the logic accordingly in your code. So any
Okay.
protocol you want to see, you can just type RFC and that protocol name.
Just a quick info on the RFC. I think recently there was one update that has come on the RFC, since we also discussed the Little Indian and the Big Indian. They actually did some performance improvement just by tweaking the order of the members in a struct. It actually gave them somewhere around 20 to 25% of a gain, just reordering the struct because of the padding issues that they had.
Okay. In which protocol?
In the TCP itself. I can send the link later, probably
Yeah,
in the
you can
Discord.
send. You can send.
Yeah,
you mean
it's a good
HTTP or TCP? You are saying
HTTP over the TCP. I think they actually tweaked the TCP itself.
Could be possible.
I
Yeah,
can,
you can send the link.
Yeah, I can send the link. It's a good read. It also speaks the way we need to take care of the padding stuff when we are actually writing our own raw sockets with the struct that we are defining and the order of the members that we define in the struct.
Yes. Completely agree.
Just a info, but yeah, I'll send it in the Discord. Yeah.
But now these days, Google Protobuf is the protocol by choice, right? Like for send receiving data, they are supposed to be most efficient.
But that is not for the HTTP. That is different. Protobuf is used.
That's an encoding.
No. Protobuf is used only
Isn't
with
it
those.
The IPC only for the processes in the same system? No.
Yeah, so that is what is that protocol when you are doing the communication between the same microservices and all? What is that called?
REST, you mean?
Not REST. REST is on top of HTTP. RPC. So suppose gRPC is there, no? Which is a protocol by Google. So RPC protocol. So if you're using gRPC, then you use protobuf and all.
No, we are using protobuf on WebSockets, and it's just
You
an
can
encoding.
You can use, but then
it's a serialization, deserialization.
Correct. You can use. What I'm saying is, if only if you know both the parties, like you are coding the server also, client also,
right.
then only you will, because that protobuf file should be present in both the sides,
Correct.
on
the
the client
schema.
side, and schema should be present on both the sides. If you do not know, then you cannot use protobuf.
Perfect. Yeah. Right.
Yeah. Okay. So wrapping up for today. Let's meet tomorrow, and please join, and please try to do the whatever we have done till now. And this will be important. So yep. Bye. Bye everyone.
Okay. Bye.
Bye. Hey, any feedback and all, you can also tell me if something is not going right, because even I am taking the class for the first time, this particular networking and all. So you can tell me if something is not going right. Right?
Can we have
No
C++
need to hesitate.
Hackfest? Can we have C++ Hackfest? I see many good C++ programmers. So
yeah, many good C++ programmers there, but no one is active.
Yeah.
I thought we'll have a good C++ community. People will be sharing a lot of things, but no one is active. Okay, fine. Bye. Bye, everyone.
Bye.